And so let's talk about Hess's law now. And Hess's law simply states that that if I don't know the delta H of reaction for any random reaction, but I do happen to know the delta H of reaction for each individual steps, I can add them up. As I mentioned before, Hess's these are chemical equations, and it's just like in mathematics. I can add them up, I can reverse them, I can do whatever I want. This is going to be very similar to mathematics. So if I have 10 for the top reaction and 15 for the bottom reaction, if I were to add them up, well, A plus A is 2A, B comes down here, D can go down here, but I have a D on the other side, so they'll cancel out, just like in math. C goes down and E goes down, and so this is my net reaction when I add these two up, and if this is 10, this is 15, now this will be 25. Okay, as we mentioned before, if you were to reverse this reaction, so E is equal to A plus D, it will be negative 15, and so on and so forth. So, so these are the rules I just mentioned. A plus B goes to C. If it's 10, then C going to A plus B is negative 10. All right. If I have A plus B going to R, that's 20. If I triplicate the whole thing, I'm going to get 60. Okay. And so let's look at an example, and hopefully that will make a little bit more sense once we do this. But it's sort of like playing around. There's not this particular thing I can't give you a recipe for. You're gonna have to kind of play with it depending on the reaction given. So I have C as graphite. Okay, reacting with hydrogen gas, forming methane. And let's say I don't have delta H reaction for this, but I want to know. So the question is, what is this? All right. So I'm going to give you a set of reactions. This is how it's usually going to work. I'll give you a set of reactions. I have C plus O2 going to CO2. I'm going to omit the states, but this is graphite gas. This delta H is negative 393.5 kilojoules per mole. Okay, I have reaction B, H2 gas plus 1/2 oxygen gas. That reacts to give me liquid water. And this delta H of reaction is negative 285. So this is all given to you in the question. 285.8 kilojoules per mole. Okay, again, this per mole thing means that if I multiply this by 2, I double that. That's all that means. And I have reaction C. I have methane gas plus 2 oxygen gas will form carbon dioxide gas plus 2 water liquids. And this one is going to be delta H of reaction is negative 890.3 kilojoules per mole. Okay, so that's the question I have. So obviously every question is going to have different steps. So I can't give you a recipe as to how to do this, but you have to kind of play around. So what I'm going to see, I want C and H2 together on the reactant side, right? I want C and H2 on the reactant side. So I'm looking here, what do I see? Well, reaction C doesn't have H2, so I'm not going to involve it for the moment. But reaction A and B do. And if I add them up, then I'll get C and H2 on the reactant side. So that sounds about right? Now, I want 2 hydrogens on my thing here, not 1. So, and I have 1 hydrogen here. So how about I'll take A and I'll take 2 of B's, then I'll get C and H2 together. So first step for this particular thing, do A plus 2B because it gives me C and H2 together on the reactant side, which sounds appealing to me. Okay, so that means if I'm looking at A looks the same, so I'm going to have A is C plus O2 is CO2 with negative 393.5 kilojoules per mole. 2B though, this is A, 2B is double B. So now I'm going to do 2 H2s plus, well, 2 times a half is 1, 1 O2, and that's 2 H2Os. 2 H2Os. And now I will have twice this. So negative 285.8 times 2, which if you, so this would be the amount here in kilojoules per mole. Okay, so I'm going to add them all up. So add this up. Imagine I have a big plus here. So I have C, that stays the same. I don't have C on the other side, it doesn't cancel out. I have O2, I don't have O2 here, but I do have O2 here, so I can do C plus 2 O2. And I have 2 H2s here, nothing on the other side, so plus 2 H2, great. And now this is going to react and form CO2. I don't have CO2 anywhere else, so it stays as CO2, and 2 H2Os. And now my delta H for this would be the summation of negative 393.5 plus 2 times negative 285.8. So you punch that in, and you get that this is negative 965.1 kilojoules per mole for this particular reaction. This is not what I want yet. But if I did want this reaction, look, I just figured out the delta H of reaction for this. But that's not what I want. Okay, so now I simplify that. We still have oxygen in the reactant side. I don't want it. So I can use reaction C and try to get rid of O2 because I have in reaction C, let's go look at it. Here I have 2 O2s, which I want to get rid of 2 O2s. But I have 2 O2s on the reactant side. If I flip this reaction and put the 2 O2s on the other side, then I can cancel out my two O2s. I don't want it. So first of all, reverse reaction C, because I want to cancel out my O2s. So if I reverse my reaction C, I just change the negative to positive for the delta H of reaction, and I put the reactants on the product side and the product on the reactant side. So I get CO2 plus 2H2O. That goes to CH4 plus 2O2, and now my delta H of reaction is going to be positive 890.3 kilojoules per mole. Now add this negative C to this A plus 2B that we already did. Okay, so this here, this guy here, that's already A plus 2B. And this guy here, that's already negative C. So what I'm saying is add this and this together. And when you add them up, you also add these, the delta H's. They go along for the ride. So if I add them up, look what happens. C is here, is nowhere here. So C comes down. I have regular C. Okay, C will be happy. C doesn't change. O2, great. I don't have O2 here, so it doesn't change from this. But I do have O2 here, so they'll cancel. So O2s cancel. I have exactly the same amount, so they cancel. I don't have to write anything down. H2, okay, I have H2 here. I don't have H2, and I don't have H2 anywhere here. So that just comes down regular. Okay. Going to the product side now. Okay, I have CO2 here and CO2 here. They go away. And I have 2 waters and 2 waters. They go away. Okay? And then I have CH4 as a lone product, which if you go back to our original question, that's what I wanted. C plus A2H2 to go to CH4. That's it. Now I will add up this and this. And that will be my delta H of this reaction. And when I add them up, that's negative 74.8 kilojoules per mole. So I know it's a long way to London, I know, and it requires some sort of moving things around. But that's kind of like, it's like a game of playing with equations and figuring out how to add them up meaningfully to get to what you need. I needed this, and this is specifically what I asked for, this negative 74.8, okay?